All right. Hey guys, this is the second video. Apologize for before. Describe transformations in graph trigs. So we're going to have two type of questions, and there'll be like two each probably. One is actually graphing it with all the amplitude period stuff, and one is just going to describe transformations. So let's say, for example, I had sine 2x minus 5. So here I'm just going to add, let's put a -3 here. From here, I'm just going to ask you what the transformations are. Now, when I talk about the transformations, this sticks to the old version of transformations. You could use the new language too, like amplitude, but it's going to use the old version of transformations again. So you could use the old ones or you could use the new ones. So for example, for this one, and I should say compared to sine x. So for this one, I would say it has a vertical stretch of 3, or in other ways, you could say the amplitude is 3. Either answer is good. You know, if you say vertical stretch of 3 or amplitude of 3, that's fine. You do need to mention in this one, there's a vertical flip. That's got to be said. There's no really comparison to that. So this right here is, instead of a vertical stretch, you got to think of it as a vertical or a horizontal. Since you know it's going to be usually 2 pi over b, right? 2 pi over b, right? That means the bigger the number, the b is, the smaller, or I guess more squeezed it gets. So this is going to be a horizontal squeeze by 2. It's a horizontal squeeze by 2. If you want to, you could also just list the period, which is the period is pi, however you want to say. So either one's okay. And then this one's just a vertical shift of down 5. Yeah, and then that's the same thing as saying it here. If you really needed to, we never talked it, but you could say the midline or the middle of the wave is at -5. That is not very necessary. Down 5 is just much more intuitive. Okay. All right. So that's like describe the transformations. That's kind of more of the old version of transformations that we did where you were more used to. Let me talk about the graphing. So we have, for your graphing, I'm only going to focus on sine, cosine, and tangent, cotangent. For cosecant and secant, I will say do not worry about the graphing of them. It's good to have that knowledge, but I'm not testing on the how it looks like or the domain or range of that. So we're just going to focus on sine, cosine, and tan, cotangent. So it's probably going to be one sine or cosine and one tan and cotangent. All right. For sine and cosine, we have the amplitude. The amplitude is going to be whatever the A value is. We have the period. That's going to be whatever is 2 pi divided by your B value, whatever your B value is, okay? That's amplitude, period, horizontal shift. That's going to be your H value. Your vertical shift, that's going to be your K value. For your domain, for domain of sine and cosine, it's always negative affinity to affinity because you could plug in anything. There's no problem there. To affinity. And then the range for this will always be based off the middle line. So it's based off the middle line. Wrong bracket. Here you go. The middle line, which is going to be in this case K, then wherever K is, you're going to go down the amplitude. So we're going to say K minus A. And then we're going to go up the amplitude. So K plus A. This one. That's true for sine and cosine. The actual shapes for sine, remember, you're going to be starting at 0 and you're going to go up, down, up. And remember, you're going to do 2 periods, okay? But the main concept is up, down, up. While cosine, when you start, is going to start at the top, down, and then back up. That's 1 period. Notice this is going to be the same thing. It's just shifted a little bit. Okay. So the look should be the same after you do a couple of waves, you know? All right. So that's sine cosine. I think that's a little bit more. We did like 3 days of that. You should feel comfortable with that. Let's talk about the other one, tangent, cotangent. So amplitude. There's no real amplitude or not needed or unimportant. So you could say whatever the A value is, but if you leave it, not leave it blank, but you just say no amp would be probably more correct. But again, the amplitude for tan and cosine, the A value does change it, but it just makes it go up higher or lower. So it's not that big of a deal. All right, the period is going to be pi over 2. The reason it's or pi over b. The reason it's pi over b versus 2 pi over b is because a normal tan wave does its full cycle with one pi, and thus you don't need to go 2 waves. Okay, you could always do it in 1 pi. The horizontal shift is again the h value. The vertical shift is again the k value. The domain is going to be, there's a little space. Well, first let's just talk about the range will be all reals. So from negative affinity to affinity. But the domain, which is the hard part, it's going to be x does not equal, I'll write it with my hand. Let me just write it like this. X is not going to equal. Now, in a normal tan wave, you have this, and then you have an asymptote, and you have this, and then you have an asymptote. So you need to deal with the asymptotes when you talk about the domain. So the x does not go to equal for the domain. It is whatever your period is, we'll call that P. So it's going to be the period times your n value. This is going to represent how big each asymptote is. This is the period times the n value. You could think of it as the same thing as mx from a slope. It moves one period at a time. But we have to start offhand. So we're going to start at half the period. So P over 2. So the first point is going to be P over 2. Another way we could write this is with P on the outside, n plus a half. Might be a little bit easier to write if your period is complicated. It doesn't look good in a fraction. Either answer is okay. So for example, for the base form or the parent function of this, the period is typically pi. So pi n plus pi over 2 equals pi n plus a half. These, either one is okay. You don't have to put both, but either one is okay. Sometimes I think most people find this one easier because the P is only in one place. This is always the same, actually. So the P is only in one place. There is something that horizontal shifts could affect it. I'm going to tell you right now, that is a complicated thing that we don't even do in honors. So you do not need to worry about horizontal shift affecting the domain in a tangent one, which I guess you could infer from that there will be no horizontal shift in the tangent question. I guess you could infer from that, but either way, the domain will be something like this, okay? If you had a horizontal shift, you have to account for that, but I'm not going to, that's like a thing that we don't even do in honors, so we're not going to bother. Yeah, that's the concepts of the graphing. I'll post some worksheets for you to do practice on. Thank you.